The lighthouse, and this lighthouse is 30 meters tall and it's 20 meters away from the person looking at the lighthouse. Work out the angle of elevation. Elevation means you're looking upwards from the top of the lighthouse to the point on the ground. Well, guys, we're not going to lose much sleep over this. It's a right angle triangle. There's your right angle there going halfway through it. What two sides do I know?
20 and 30.
We know 20 and 30. I like the names for that. 20 and 30. Opposite and adjacent. And then, as Moses already said, it's TOA, which is a tan of whatever this angle is. We'll call it tan A. Sorry? Pythagoras' theorem would give us the length from here to here. Well, what they're looking for us to do is to find the, to the nearest degree, they want to find out the angle of elevation. So Pythagoras' theorem will get us the length, but it doesn't get us the angle of elevation. Excuse me? Now, tan A is 30 over 20, and James has got a tan inverse 30 over 20 for us, and what you get, James? Tan inverse 30 over 20? What you get? 56.3. Sorry? 56.3. 56.3, round it down to 56. Everybody happy enough with that?
Is that it?
Yeah. Jesus. Rory. Okay. Now, what we have next is a swimming pool, okay? And once again, first thing you might say to me is, well, look, there's no right angle triangles there. Wrong. Right? It's up here. So, there's our right angle triangle there. Now, how do you get the measurements on this right angle triangle? Well, I'd argue that this is still 2.5. I'd argue that this length here is going to be 36 meters. Where did I get 36 meters from? 50 minus 14, 36 tall. And then it's going, theta is the angle. And how do you find out what theta is? Well, if I draw another triangle underneath theta, like this, theta is the angle. It's just a symbol. It's basically a circle with a line going through it. It's a Greek symbol. Okay? Now, it basically represents x. You could call it x if you want, and then just change it back at the end. Anyways, this is called theta, okay? And basically, guys, what length is it from here to here? Can anybody tell me? 36. And what length is it from here to here? 2.5. Alright. And what two sides do I have relative to this angle here? What are the names of the sides? Opposite and adjacent. The hypotenuse would be the red one going here. Okay? So, what function are we using? Sine, cos, or tan? Tan. So tan, theta, is 2.5 over 36. To get theta on its own, how'd you do it? Tan inverse 2.5 over 3.36, and what do we get? It's going to be a small angle because it's not very tall, but it's extremely wide. So what is it? 3.97. 3.97, and to the nearest degree? 4 degrees. Now lads, you can see they're actually reasonably easy, aren't they?
Yeah.
Now, next one, question 8. Now question 8, different kettle of fish altogether. Okay? Question 8, instead of having one triangle, has two triangles. Now, what we're going to do here, without even getting too concerned about all the language, okay? You go, what is the length of GH? GH is from here to here. Well, I'd argue that G to H is 5 meters. Anybody would inclined to agree with me?
Yeah.
Same as we're assuming that the guy is standing straight. So in effect, the question is basically almost like this. The question is like a rectangle, and underneath in the rectangle, there's going to be a triangle above the rectangle. So it's basically a triangle above a rectangle, and out of the other triangle, out of the rectangle, we can make a second triangle. And they're both. We're just going to use triangle 1 and triangle 2. Is everybody happy with that? Yeah. That's basically what we're using. And triangle 1 has 59 degrees and has a length of 5 because the bottom is 5. So, long story short, GH is 5. Work the length of TH out. Well, TH, if this is 5 and we want to figure out what TH is, can anybody tell me what side is TH compared to the 59 degrees?
Opposite?
Opposite. And what length is 5 compared to the 59 degrees? Adjacent. So tan 59 equals TH, or whatever letter we want to come up with. Call it X, I suppose, yeah? So it's going to be X over, anybody? 5. Where does the 5 go? 5 tan 59, X therefore equals?
8.32.
8.32. To one decimal place, 8.3. What other calculations need to be made to find the height of the tree? Well, the height of the tree goes from T all the way down to the very bottom. What I'd like to get, I already know what the red part is. If I found out what this blue part was, I could add the blue part to the red part and get the height of the tree. Everybody happy with that? So, to get the blue part, we'll just make another triangle, and we call that 20 degrees, this length being 5, and I'm trying to find length Y. Anybody tell me how to find length Y? Anybody talk? 90 degree triangle, find what Y is.
Opposite over adjacent.
Opposite over adjacent again. Y being the opposite, 5 being the adjacent. Which function do we use? Tan. Tan 20 equals Y over 5. Y therefore equals 5 tan 20. And what's 5 tan 20?
1.81.
Huh?
1.81.
1.81. 1.81.
1.81.
Okay. 1.81, alright? So, 1.81 plus your 8.32. And what's the two of them added together? 10.13. And correct to one decimal place? 10.1. Okay, lads. So,